everybody. So if you just want to follow, you can also find the slides next to the paper online. So if you have a laptop and you can't see till the front. So I'm going to talk to you about the Moldable Inspector. So first, does this look familiar to you? If not, it's the debug perspective from Eclipse. And we have here the stack, so the runtime stack. We have here the code editor, and we have here a tool that we're going to focus on, and this is often referred to as the object inspector. And it's usually very, very tiny. So let's make it a bit bigger. So if you look at its structure, we have a column that displays the names of the attributes from an object, and we have another column that displays simply their values, and usually this is a tree, so you can expand it. And this is how it looks in Eclipse, and this is how it looks in Faro. So Faro is a dynamic object-oriented language, Smalltalk inspired, and if you look at the inspector, by default, it's the same. This is the same view. The main difference is that this column is named variable instead of name. So that's the biggest difference. But now I have a quiz for you. What object is displayed here? You can see its state. No, it should be obvious. You have the state. What else do you need? Yeah, you can. I guess you read here, no? Or, yeah, it's actually a graphical window. And it's hard to guess, actually. Let's look at another object. What object is here? It's a parser created using parsing expression grammars, to be more precise. We can look at another, and this is a chart. I will save you the trouble. And we can look at another, and that's a folder. And now let's have another. So I just told you. Graphical window, parser, chart, folder. So let's have a quiz. If I mix their order, where is the chart? Let me help you a bit. It's here. So these objects belong to four very different domains. And yet, we displayed them just using the state. And this seems to be it's quite often they are just displayed like this. And to try to see what's happening, we did 16 interviews with software developers. And first, we asked them, what's an object inspector for you? And they all gave this definition, a tool showing the state of an object, more or less. You can find the answers in the paper, but they're more or less along this line, something that shows you the state of an object. But then we asked them, okay, tell us how you use an object inspector, tell us what objects you inspected recently, what problems you had, what you tried to do. And it turns out that what they wanted was a tool to help them understand an object. And showing the state and helping somebody understand an object are not the same. There is a contradiction between the two. And now let's see how we try to address this contradiction. So first, here is our graphical window. And when I have a window, I really want to see how it looks like. So we can have a view that simply shows its visual representation. And now we can see it's actually a color picker more than just a window. And then whenever you deal with graphical components, usually a graphical component never comes alone. It's a graphical component embedded in another one, embedded in another graphical component, and they usually form a tree structure. And again, sometimes you want to browse that structure. Using the state view can be quite complicated because there are a lot of other attributes. So you can just display another view for the same object that simply shows the containment structure in terms of graphical components. So these are three views for the same object. And that's the main idea behind the Moldable Inspector. It allows every object to have multiple interchangeable views. And you can select them dynamically at runtime if you want to. Of course, there is a problem of how to display them, and for that we chose the easiest solution. We just group them together using a tab widget. So at the top you have the tabs that represent different presentations. So that's one part. But then you rarely need to look at one single object. You need to somehow look at multiple objects. And to support that, whenever you select an object, so for example, if I'm selecting this object, we open it in a new pane to the right. And then we can continue this. So I can switch here to the submorph view. I can expand it. I can select an object, and then another pane. Then you get another pane to the right. And if you continue this process a few more times, notice that these start to shrink. And if you go 5 more, they will be really tiny, and that's a bit annoying. So to solve that problem, we basically only display a certain limited number of objects, and then I have a video. We have a scroll bar at the bottom. Does it start? Yes. So there's a scroll bar at the bottom to which you can go. Every object is a circle, so if you hover, you get a preview, and if you click, it will navigate. And then you can always expand the length to which you look at that session, so change or decrease the numbers of visible objects. So in this case, I'm looking at 3, and now I just want to see 1. So now this is the normal inspector, and now let's go back to 2. And that's the second idea behind the Moldable Inspector. We always track your current exploration path, so you can always reason how you got from the initial object to the current object. And then you can change the lens through which you look at that session, at that path. But then, it's not always the case that the object you want to inspect next is actually stored in an instance variable in the current object. It can happen that it's not there. And let me give you an example. Here we have an object that represents a text editor. And here is just how it looks like. So we just have some text, and in this case, I selected the whole text. And when you right-click on the text, you'll get a context menu. And the context menu is yet another graphical object. And I want to navigate to that one. But you can't from here. So you could switch to the raw view, but it's not stored actually in the state. It's something that's dynamically generated when you right-click on the text. However, you can generate it using code. In this case, is this small snippet over here. You don't have to read it. So you can just tell the object, OK, give me your context menu. And then I can execute this code, and I get the object that represents the menu. And I couldn't do this if I don't integrate code, because it's not stored here, the menu. It's nowhere. And then here it's a simple menu, and it has the option copy. So if I want to look into what this copy action does, I can just click on it. Why not? So you can click, and then if you can't read this, it's a menu item morph. So you just get a part of the UI that represents that menu item. And for example, I want to execute it. I could switch to the raw view, use some code. So I just say do button action. So because it's copy, it will copy the selected text to the clipboard. And my second line, I'm just asking the clipboard for the current text. And if I execute this, I get the code that was actually in the editor. So I can check that, did it work? And this looks very much like a Pharo script, so I can execute it. And then I get another object, the result. And in this case, the result is an object of type RTView. That's a library for building charts, and I can display just a view that shows how it looks like. And if you go a bit back, here every time we had a quite different navigation mechanism. So we never just rely on object state. And that's the third idea, the fact that we support a flexible navigation that allows you to easily integrate code into the navigation process. Because again, if you just move through object state, you are quite limited about what you can do. And I talked a lot about presentations, but I never show you how to create them. So let's move to that part. So for that, we'll use this one. So this is the view that shows the graphical structure. And for creating presentations, so every presentation is created as a method that is defined in the class of that object. So to create this view, I will use this code, and I will place this code within the class of that object. In this case, the class of that object is called morph, and this is just a simple DSL, so an internal DSL that we use. And to access it, so for example, you are in the inspector, and if you want to access this code, you can just do it from within the inspector. Because every object has a presentation that's called meta that gives you access to the source code of that object. And since this is in the class, you can just access it. And a funny thing that you can do, and quite useful now, is that I can open the same object in 2 panes. In the second pane, I will have the presentation that I want to create. And in the first pane, I have the source code of that presentation. So then you can, every time you write code and you save, the inspector refreshes, and you get a bit of a live editor to create presentations, again, directly within the inspector. And most of the presentations that we developed are actually like this, because it helps to see what you're building. Otherwise, you're a bit lost. And I said we have a DSL to create presentations. And we optimize the creation of certain types of presentations. So lists, trees, tables, text, source code, and then you can have presentations created with several types of libraries. So if you want graphical views, you can use Rasal, or Glamour is a more fancy library for building data browsers. And we are using them all. We are using less the tree, because the way you navigate to less, you need trees less, not so often. And until now, we and the Faro community created around 186 extensions. So this was at the time when I made the slides. Now there are a bit more. And on average, so this is just a histogram showing the distribution of the size of an extension. So here it's 8 lines of code. So on average, extending the inspector with a new presentation took around 9 lines of code. Of course, if you have more complex objects, you write more code. But if you have to write too much code to create a presentation, that may be a sign that, okay, you might need to redo something, redesign your objects, maybe. So that is the fourth aspect behind the Moldable Inspector. We allow the inspector to be easily extendable, even at runtime, from within the inspector with new views. And these were the 4 things that we mentioned, the 4 ideas, and these were actually the results of our interviews. So we had a set of interviews, we coded the interviews, and we look at what are the things that repeat the most, and in the end it were these 4. And since 16 developers is not so much, we also did an online survey where we just asked people, do you agree with this or you don't agree? So this was Likert scale, and more or less everybody mostly agreed or strongly agreed. So this told us, okay, we are in the right place. And I quickly just want to show you one type of workflow that becomes possible when you have this kind of infrastructure in place. And for that, we look at something completely different, compiled code. So this is how compiled code is stored in Faro. So this is an instance of an object called compile method, and by default, it just has a list of bytecodes. And for example, if I look at bytecode 20, it's 117. Okay. But this is how it's actually stored. Sorry. However, we can have a different view. So we have a view that's labeled bytecode that shows a more human-readable representation of the bytecode. So now instead of just numbers, you have push temp, push constant, and actually bytecode 20 is push constant 0, which again makes more sense to look at it this way. And then you can select. You can select a bytecode. So I can select bytecode 21 here, for example, and then we create an object for that bytecode and we open it to the right. And then you get a presentation that shows you how that bytecode maps to source code. So then you get a simple browser just to browse your bytecode and see how it maps to source code, what part is generated. Just using 2 presentations and looking at 2 objects at the same time. And of course, another thing I want to see about some compiled code is the original source code. So for that, we have a view. It's called source, and it just shows you the source code. And we have yet another view that shows you the AST behind that bytecode. So we can expand it. And again, if you select an AST node, it will open that AST node to the right, and then you can see how it maps to source code. So you get in the inspector, again, a browser just to look through ASTs and see how it maps to source code. All again using 2 simple views to 2 different objects. And we have many, many more extensions. And just to give you a feel of how they are spread throughout the system, this is a diagram. This is a simple class diagram. So every gray circle is a class, and every bigger white circle is a package. So this is just a circular tree layout that displays the classes in the system, grouped by packages. And now with red are all the classes that have an extension. And this, for example, is the kernel package. So it has a lot of small classes. So all the basic data types have extensions. And this is, for example, a big package that just has one class has extension. So that's the graphical library. So only the root class has all extensions. And then all the other objects inherit from that one. So you don't have to repeat them if you don't need to, if you can follow. So when the inspector searches for extensions, it looks over how is it? It looks over the hierarchy, so it goes up the hierarchy. And this is mostly what I wanted to tell you today, and I started from this contradiction. On the one hand, if you just ask people what they understand by an object inspector, they will tell you a tool that shows me the state. If you ask them how they use an inspector, you will see that they want more. They want a tool to help them understand an object. And these are not the same. If we focus on this, if we focus on a tool showing the state of an object, we end up with something like this. Looks familiar. However, if we change the focus, if we focus on an object inspector that would help developers understand an object, we will reach something that is a bit different. And so this small, very change in focus can lead to a totally different object inspector. And the object inspector can move from being the simplest tool in the IDE, perhaps to being a much more important tool. And that is all I wanted to tell you. And if you want to find out more, gt.moostechnology.org, or also there is a demo tomorrow and Friday, so if you want to see that it actually works and we look at more types of objects and play around, feel free to drop by the demo session. So thank you for your attention.